If I told you on average, a given intersection has about 3 car accidents per month, does that mean that there are exactly 3 every month? No, it means that some months there might be more, some there might be less. But how often is there more or how often is there less? This is actually a Poisson distribution problem. And that's what we're going to talk about today. We're going to find the probability that on any given month, even if the average is a 3, what's the probability that next month there will only be 2? We're going to answer that and more as we make it through this video. Hey guys, and welcome back. My name is MrCaproni, and this is Probability and Statistics. Today we're going to be looking at Poisson distribution. Now, this is the third type of probability distribution that we're covering. We went through binomial, geometric, and now we're looking at Poisson. So if you haven't seen the other 2 videos, maybe you should check those out above. Now, if you have seen all those and you're following along, or you just need information on Poisson, then thanks for joining me today, and let's dive right into the material. Poisson? I usually go with Poisson. I think of it kind of like the word croissant, and if you want to sound a little bit more French, then you just throw a little bit of oomph into it. So, I go Poisson. But really, what makes a Poisson distribution a Poisson distribution? Well, it's usually when you're dealing with knowing the average of a certain number of occurrences of a given situation, and you're trying to find the probability that a number other than the average, or maybe even the average, will occur. So let's look at the 3 major defining features of a Poisson distribution. First off, you must have a set interval of time, area, or volume that's given to you. And then in that amount of time or area or volume, you count the number of times something occurs. So in our example we talked about at the beginning today, that would be in a given month, we were looking at the number of car accidents that occurred. Now we knew that the average was 3, but we wanted to know another number, like maybe 2, for example. So in that case, 2 would be our X. The second thing is that the probability of that something happening has to be the same for the entire interval and for each interval. So for example, if I said the average was 3 this month, then the average needs to be 3 next month as well. We need the probability of that happening every time to be the exact same. Which leads us to the last one. The number of occurrences must be independent of each other. So if I have a lot of car accidents this month, that shouldn't change my average for the next month. Or knowing that it happened this way shouldn't change that way. Each one of these must be independent of each other. So one interval should not change the outcome of another interval. So at the beginning of the video, we kind of discussed what we're actually finding the probability of, but let's just go ahead and lay it out one more time. When we are dealing with a Poisson distribution, what we're doing is saying, hey, we know that there is a given number of occurrences in this amount of time, but will it always be exactly that number? No. Well, how often is it not? How often is it? Well, that's what a Poisson distribution is finding the probability of. We are actually finding the probability that a certain number of occurrences will happen in some interval of time when we already know what the average number of occurrences is. So in this case, we were talking about 3 accidents per month at the intersection. So it's not always going to be 3. Sometimes it could be 2 or 4 or 5, but they just average out to 3 over time. So what is the probability that next month we would only get 2? Or what's the probability that next month we would get 4? Or maybe we're actually looking at the probability that next month there will be exactly 3. I don't know, but that's what Poisson distribution is answering. When we are finding the probability of that situation, we are dealing with a Poisson distribution. So what things come into play when we're dealing with that formula to find that probability? Well, the first is we need to know the average number of occurrences per interval. Usually this is given to you, and it's represented with the Greek letter mu, which stands for mean in probability and statistics, which you can see all the way over there on the left-hand side of the screen. Then the second thing we need to know is our actual x, which we've already mentioned, is the number of occurrences per interval that are currently in question. So I want to know the probability that there will be 2 car accidents, then 2 would be my x. If I want to know the probability that there will be 3 car accidents, then 3 would be my x. And lastly, you need to know what E is. Now, E is not just a letter, it's also a mathematical number. It's an irrational number that's approximately around 2.71828. Now, this number is used for a lot of different formulas, and it's universally accepted. In other words, it's also even on your calculator. So E actually represents a number in this case, and that number doesn't change. It's always the same. Now that we have the notation knocked out, let's go ahead and take a look at the actual formula. Now, I know this formula looks pretty dang crazy, but remember, we actually just defined the three variables that are used in there. Whereas the mu and the x are going to change every time with the question we've been given, the e is always going to be the same, because remember, that just represents a number. So if we're looking through this here, it says that we're going to have mu raised to the power of x, or number of occurrences, times e raised to the negative mu. So we're actually using that mu twice right there. And on the bottom of the fraction is x factorial. Now, don't forget, the explanation point just means factorial. And if you don't know anything about factorials, you can check out the video up above, and that will actually explain to you what the heck an explanation point means in mathematics. So again, though, this is just going to be our formula that we're going to be using to find the probabilities that we've been talking about. Regardless of how easy that formula may look for you, a lot of people still struggle with it. So feel free to always use a ton of different free technology options that will do the work for you. Now, if you own a TI calculator, all of them pretty much do Poisson distributions in them. So you can just look out how to do that. But you also can use free programs online like GeoGebra or Desmos, or just do a Google search of Poisson distributions. Personally, I'm going to go ahead and do another video that's going to show you how to use GeoGebra to do this same thing. But for today, I'm just going to go ahead and plug and chug into that formula that we have. So the example we've been looking at is at a given intersection, there's an average of 3 accidents per month. What's the probability that next month there will be 4? So remember, if we have our formula down here, we need the mu, our mean, or our average, and we need our x, the number that we're actually concerned about for this question. Now, it mentions that 3 is the average. And don't forget, average and mean are the same thing. So that means that our mu is actually going to be filled in with the 3, while the x is going to be filled in with that 4 that we're looking at. And that's going to give us this equation down here. Remember, the e is a number, so we don't need to fill that in. Once we go ahead and plug that into the calculator, we will end up getting this as an answer, 0.168031, which essentially is about a 16.8% chance. So that means that, hey, next month, there's actually a 16.8% chance that there's going to be 4 car accidents instead of 3, when we know that the average is usually 3. The only way this really gets any harder is if you have a range of numbers you're looking for your x instead of just one. So like in this case, it says, what's the probability that next month there's going to be 2 or less car accidents? Well, in that case, I need to actually plug multiple things into our formula. I'll have to plug in 2 to find out that probability, plug in 1 to find in that probability, and then plug in 0 for x to find that probability. Now, once I find all of those probabilities, you can just add them up for the whole range, and that will give me my total probability of getting 2 or less in a given month. Now, that can again be a lot easier using technology, but if we were doing this all out by hand, we would just do the formula 3 different times and then add up all of those answers to come up with our total. Well, guys, there you have it. A Poisson distribution is when we're dealing with a mean that was given to us, or an average for a set interval. And then we try to find the probability that a certain number of those occurrences will happen in that same interval. And we just used the formula that we went through. And that wraps up the last of our 3 probability distributions. We did binomial, geometric, and now we've handled Poisson as well. So thanks for joining me through all 3 of these, or thanks for joining if you just watched this one. If you found any of this information helpful, please go ahead and hit the like button below. That helps me out. And hit subscribe if you want to keep seeing videos like this. Remember, my name is MrCaproni, and this has been Probability and Statistics. I hope you have a fantastic day.